Hello, welcome to this video. In this video, I'm gonna show you guys another formula that we can use to manipulate the way logarithms look. Okay, so we have came across three formulas. We call them the laws of logarithms. The three on the top right corner of the screen. This three over here. We already talked about them in the previous videos, and now this is the last one. Okay, so it will help a lot if you remember it. So let me show you guys how this formula can be used, and then I'll show you how it comes about. Okay, so if I have, say, log 7 to the base of 2, I can break that down saying that, okay, that will become log 7 to the base of 10 over log 2 to the base of 10. But right now, because it's not, it is base of 10, so we don't really have to write it. So that's it. I can break log 7 to the base of 2 into a fraction where I would have log 7 and log 7 in the numerator and log 2 in the denominator. Or I can also break it down into natural log, ln7 over ln2, natural log. Or I can even break it down into whatever, So now log 7, I can say the base of 13 over log 2 to the base of 13. What you should be careful with is make sure you have this a on the numerator and the b in the denominator, and make sure that they have a common base. All right. So this is how we can use this formula to change how our logarithms look. Okay, so now I'm going to talk a little bit on how this formula came about. All right, so let me remove the example here. Let me remove all this. And let's say today I have b to the power of y is equal to a. Okay, b to the power of y is equal to a. If I change this to log form, to logarithmic form, then I would have log a to the base of b is equal to y. Correct? I hope you guys are somewhat comfortable with exchanging between log form and exponential form now. So I'll leave like that first. So my y is equal to log a to the base of b. And that is just simply the logarithmic form of my original exponential equation. Okay? And we'll come back to that later. So now, if I'm going to go back to my exponential equation, and I'm going to take the log of both sides. Okay, I'm going to take the log of both sides, and I'm going to rewrite that just to so that we can see a better picture of it. I'll have log b to the power of y is equal to log a. And some of you guys might be thinking, I can pull that y to the front because it's the exponent. That's one of the laws of logarithms, right? I can pull the y to the front, so I will get y times log b. In this case, remember the base is 10, yeah? Because we don't write the base, which means by default, the base will be 10. This is equal to log a. So if I make y the subject, I will have log a over log b. So log a over log b. This is equal to y, and previously we already said that my y is also equal to log a to the base of b. This is also equal to log a to the base of b. Right? So we have just proved that this is how we got the formula here. That's how you get it. Okay? So hope you guys find this somewhat interesting. There's one very common mistake that I would like to point out, and I'm going to write that in red. but that means please do not do that. Okay, so right side, I have this part when I got to this step. Okay, I'm gonna put that aside. I'll have y is equal to log a over log b. Now, how many of you guys were thinking about, oh, I have division, so that becomes log a over b, right? So division, so I can just simplify them as log of a over b. This is not correct, right? This is definitely wrong. Please don't do that, okay? They're not equal to each other. Or some of you guys might be thinking that this is wrong. Some of you guys might be thinking, oh, this is dividing, so I can use this property right there, right? I can use that property. So divide as subtract. So let me subtract them. So I'll get something like, oh, this is equal to log a minus log b. This is also incorrect, right? That's also incorrect. So please make sure you don't make those mistakes. I've pointed out all these videos that I've made. I always try to point out common mistakes that I see from the students. Please be aware of what you are doing with your workings and try not to repeat those mistakes. Yeah? So please, common mistake here, just be aware of them. Alright, now I'm gonna show you guys a few examples. Okay, so I want you to pause the video and take a look at what you have to do here. Okay, welcome back. Hope you understand what they want. So all we have to do now is to express this in terms of y. So I need to write this part is equal to something something y, right? Okay, so that's what we have to do. And it's given that my y is equal to this. Okay, so let's see. Log x to the base of 9. This is equal to, let's see what I can do with this. I'm going to try to break it down. I'll say log x to the base of 3 over log 9 to the base of 3. Why do you think I chose the base of 3 over here? Why did I do that? Why did I go with, say, log 10 over log x to the base of 10 and log 9 to the base of 10? Why didn't I choose the base of 10, or why did I not go with the natural log? Because what's given here, that has a base of 3. So I chose the base of 3 on purpose, hoping that I will be able to get something useful, and I do, because this whole thing is gonna become simply y. And what's log 9 to the base of 3? Log 9 to the base of 3, what is that? I hope your answer is 2. This should be 2. So there are many ways you can do this. Log 9 to the base of 3. You can change that to log 3 squared to the base of 3. Move the 2 to the front. I get 2 times log 3 to the base of 3. And that is just 1. So I get 2. Right? So I will have y over 2. And that's it. So log x to the base of 9 can be represented in terms of y as y over 2. Okay. One last example, and this is in fact from your exercise 4O. This is from your exercise 4O. Question number 3. Okay, question number 3. So I'm showing you guys the example from the textbook exercise. Okay. All right, so let's get started. Okay, so go ahead, pause the video and see what's given to us and try to understand what we have to do. All right, welcome back. So I have x. The x is equal to log 2 to the base of a. Y, oh, what happened here? Y is equal to log 6 to the base of a. Okay, so they're both to the base of a. And we need to represent a, b, c, d, e using x and y. So very similar to what we did just now. Let's get started then. So log 6 to the base of 2. I can write that as, since, what do you think, whatever's right now the x and y that's given to us, they're both to the base of a, right? To the base of a. So if I try to break down this log 6 to the base of 2, we should try to get a base of a as well. So that later, hopefully, we can see something useful. And we do. Log 6 to the base of a, that is my y. Log 2 to the base of a, that's my x. So log 6 to the base of 2 can be represented as y over x. Alright. Next one, let's do part B. So log 2 to the base of 6, very similar. I'm going to break it down into log 2 to the base of a over log 6 to the base of a. This becomes y. That becomes, oh, sorry, that's x. That's actually x. This is x, and this is y. So it becomes x over y. All right. What else? That's it. Now for part C, I can break this down as log 36 to the base of a over log a to the base of a. Yeah? Okay. What's log a to the base of a? This is simply 1. And so I will have log 36 to the base of a. But is that it? Right now, this is simple. We are simplifying this a little bit, but it's not helping us because I'm not sure if you guys see that, I'm back to where I started. So that's not very useful. That's not very useful at all. So let's see what we can do to make it into x and y. So what I'm going to do is I'm going to try to break this 36 into using 6. So this be 6 squared, correct? So I have this 6 squared, which came from the 36, and I'm going to bring that power. I can bring that power to the front. That gives me 2 log 6 to the base of a. And log 6 to the base of a, that gives me y. So my answer will be 2y. That's it. So please guys, don't just jump straight ahead. So I've been changing the base for my part B and my part A. So for part C, I'm also going to change my base. That's not how it works, right? Because when you guys are taking a test, taking an exam, in fact, when doing math, even though practice makes perfect, but it would be a lot more useful if you're aware of what you're doing and why you're doing it. Okay. All right. Let's go with part D then. If you look at part D, there's already a base of A. So do you think I'm going to change the base? Nope, I'm not going to do that. Instead, I'm going to do this. 24. Let's break it down. So that will be 4 times 6, yeah? Which is equal to, now I can use the property to help me out. I can have log 4 to the base of A plus log 6 to the base of A. And this is equal to log 2 squared to the base of A plus log 6 to the base of A. And log 6 to the base of A, this is simply my y, so plus y. I can bring the 2 to the front. I'll get 2, and then I'll have log 2 to the base of A plus y, and this becomes x. So my final answer is 2x plus y. Okay. Now last two. Let's finish this. So log 12 to the base of 6. I will have to change my base for this one. So this becomes log 12 to the base of a over log 6 to the base of a. And I can break the 12 into 2 times 6. Oh, sorry. With an a there. This is 2 times 6 divided by log and my log 6 to the base of a. This is my y. So this is my y here, and I can break this down into 2 log adding each other. Okay. Over y. So this becomes x, that becomes y. There you go. My final answer is x plus y over y. This is a bit tougher, but again, we're just using the laws of logarithms to help us to manipulate the expression. Yeah? Alright, last one. Let's finish this. So log 3 to the base of 2. Since I need a base of a in for my x and my y, I'm gonna introduce that. Then I will have log 3 to the base of a over log 2 to the base of a. And log 3 to the base of a, I don't see anything that I can use there. But for now, I can change the denominator to become x. But for the 3 is equal to 6 over 2, correct? Which means I can write the numerator as 6 over 2. And you guys might be able to see why I do that. So here I could use the property. Which one is that? Okay, there you go. This one right here. So log x over y is equal to 2 log minus each other, right? So I'm going to do that. I will have this become log 6 to the base of a minus log 2 to the base of a, and the whole thing, yeah, the whole thing over x. And this is y, this is x, so I'll have y minus x over x. Alright, this is it. You guys should be good now. We will work on the exercises in class, and I'll see you in the next video. Bye bye.